Okay, I've learned a number of ways to simplify square roots, and I've seen it taught a number of ways. I'm going to try to show you the best way out of all the ways I've ever learned and out of all the ways that I've ever taught, the best way that I've ever found for simplifying square roots. But in order to do this method, you have to be able to list off perfect squares first. So we're going to create a list first, and notice how I got the list. Maybe you'll see the pattern. 1 squared is 1, 2 squared is 4, 3 squared is 9, then I have 4 squared is 16, 25 is 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. I can keep going as much as I wanted to, okay? I'm going to have this list. I'm going to keep it handy because this list here is going to be what is the key to solving all of these problems down here. Now, I want you to keep in mind that sometimes, if you have a calculator handy, sometimes we get lucky and we get something like the square root of 81, and the square root of 81 is a number that's already on this list. It's 9 squared. And that's important because the square root of 81 is 9. There's definitely a relationship between what you see on the list here and the numbers that you're going to see inside the square roots here. Square root of 81 is 9. That's a nice, neat number. Square root of 100, if we put that in our calculator, it will return a nice, neat number. The problem is whenever you try to do a problem like the square root of 27. If I take 27 and I square root it, I get 5.19615, blah, 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 blah. It's not a nice, neat number, right? So we need to be able to simplify it, and that means that we do this the best way that I know how. I go up to my list of perfect squares, and I find the biggest perfect square that will pull out of 27, that will factor evenly into 27. So I'm going to start right here. 25 does not go into 27. 16 does not go into 27 evenly, but 9 does. And so I'm going to rewrite 27. Instead of 27, I'm going to use 9 because that was the biggest one. I'm going to say instead of 27, that's really 9 times 3, right? 27 is 9 times 3. And anytime I have, now this is be careful here, anytime I have multiplication going on in here, not addition or subtraction, but anytime I have multiplication, I can split that up into two separate square roots. The square root of 9 times the square root of 3. And now you might notice the reason that when we're picking values that are out of this list is because I know the square roots of every single one of those values. I know what the square root of 9 is. That's why I picked that one out. The square root of 9 is really just 3, isn't it? So instead of calling it the square root of 9 times the square root of 3, I'm going to call it 3 times the square root of 3. And it turns out that the 3 square roots of 3 is the same thing as the square root of 27. Watch on my calculator. Ready? 27. I'm going to take the square root of that. It's 5.196. The square root of 3 is 1.7. If I take that times 3, it's 5.196. Those are the same decimal. They mean the same thing. So you just simplify the square root. Let's try this example down here. Okay, square root of 75. I go to my list and I say, okay, I'm going to start right here. I'm going to work my way down and find out what goes into 75. 64 doesn't. 49 doesn't go into 75 evenly. 36 does not. 25 does. 25 does. If you think money, right? Think quarters. So instead of writing the square root of 75, I'm going to write the square root of 25 times 3. 25 times 3 is 75. And that means then that I can split that up into the square root of 25 times the square root of 3. And now we know the reason why we picked the square root of 25, a number off that list, is because we know that square root of 25 is just 5. So instead of the square root of 25 times the square root of 3, I say that it's 5 times the square root of 3. Those would give me the same decimal in my calculator. Now every once in a while you might see something like this where they actually throw in a number outside the square root to begin with. And I want you to understand that that's actually not that complicated of a problem. What we're going to do is we're going to attack this first. Let's figure out what the square root of 45 is first. And at the very end, we're going to multiply our answer by 3. That's all it is. It's 3 times the square root of 45. So I come up to my list, and I'm going to start right here. The biggest number that goes into 45, not 36, not 25, not 16. 9 goes into 45, though. 9 times 5 is 45. So I'm going to rewrite this then as, instead of 3 times the square root of 45, it's 3 times the square root of 9 times 5. And the reason I chose that is because I can rewrite that as two separate square roots. 3 times the square root of 9 times the square root of 5. And now the reason I picked a number off of the list up there, because I know the square root of 9, that's 3. So I have 3 times the square root of 5. And now I'm going to take the numbers outside the square roots. I'm going to combine those. 3 times 3 is 9. So my final answer is 9 square roots of 5. That's the same thing as 3 square roots of 45. In your calculator, if you put both of those in, they would give you the exact same decimal. Okay, one more. 6 square roots of 108. The only reason I chose this is because it's just a little bit bigger. Okay? So I go through my list and I say, okay, 100 doesn't go into it, 81 doesn't, 64 doesn't, 49 doesn't, 36. Does 36 go into it? I've already forgotten. 36 does. It goes into it 3 times. So instead of writing 6 square roots of 108, I'm going to write 6 times the square root of, and that's 36 times 3. I split that into 2 separate square roots. I know the square root of 36 is 6. And now I just multiply the two numbers on the outside. 6 times 6 is 36. So that's the same thing as 36 times the square root of 3. You just simplified now a bunch of different square roots, right? Look pretty complicated. The key all rests in this, though. One last note, every once in a while you're going to get a problem like this, the square root of 29. And if I go through my list, I'll draw all the ones up to 29, okay? If I go through my list and I find out that none of them go into 29 evenly except for one, that means you're done. That means it's as simplified as it gets. You stop right there. If none of these numbers in the list factor evenly into the number inside the square root, then you don't do anything with it. You leave it alone. It's already simplified. Hopefully that makes sense. I'm going to make another video here in just a second that talks about adding and subtracting square roots. And then I'm going to make another video after that that talks about how to rationalize the denominator.